Okay, let me read out the question for you. Cadmium is found in small quantities wherever zinc is found. Unlike zinc, which in trace amounts is an essential element, cadmium is an environmental poison. To determine cadmium ion concentration by electrical measurements, we need to construct the standard electrode potential for cadmium 2 plus cadmium electrode. The voltage of the following voltaic cell is measured. What is the standard electrode potential of zinc cadmium 2 plus cadmium electrode? When we know the E cell, which is good point, okay, and when we know the copper 2 plus reduction, then we can calculate oxidation or reduction potential of cadmium. It's quite easy. And we know 1/2 cell of reaction. Okay, let me write down here. This is voltaic cell, this is battery cell. Right compartment minus left compartment, and we conclude that the E cell is 0.743 volt, and in the right compartment cadmium reduction. And 0.743 volt, 0.30 volt. So cadmium reduction potential is 3 volt. So minus 0.403 volt. Okay, and let me write down so that you understand it. This is reduction potential of cadmium. So we conclude that cadmium is difficult to reduce into metallic form because reduction potential is negative value. On the other hand, oxidation potential of cadmium is plus 0.403. So we conclude that can easily be oxidized. Cadmium gives off 2 electrons and becomes cadmium 2 plus, okay, easily oxidized because this is an active metal like zinc, iron, manganese, aluminum. Let's remember when they look at the reduction potential of silver, for example, E voltage is plus 0.8 volt. So can you see the difference, huge difference? And this is the reason why silver is difficult to oxidize. And this is the reason why cadmium is easily oxidized to give off electrons. And then we also conclude that cadmium, if something is easily oxidized, it becomes a strong reducing agent. So we can write down here cadmium, but in the form of solid metallic form, is a stronger reducing agent. Maybe more stronger than tin, but weaker than iron. Weaker than iron. And also weaker oxidizing agent than tin. Anyway, this point is not important. So using this kind of reaction, we can calculate each species oxidizing properties, oxidizing potential, reduction potential. Also, we can calculate E cell, galvanic cell, voltaic cell, etc. Okay. Now let's look at the use E data to determine delta G for the reaction here. This guy oxidized, and this one is reduced into zinc chloride, as you see here. This is a voltaic cell in the first example. This is now and there is a relationship between E and delta G value, and this is NFE. Okay, E cell. This is for the standard situation, and this one is non-standard situation. And we remember this one. And delta G standard. How many electrons are involved in this question? As you see here, zinc gives us 2 electrons. So it has to be 2 times Faraday constant 96,485 Coulomb. 1 mole electron times 2.121 volt. And delta G value is minus 0.093 times 10 to 5 joule. And we convert this one 9.3 kilojoule per mole. When 1 mole zinc in solid form reacts with chlorine gas 1 atm, whereby zinc chloride 1 molarity is produced, and the Gibbs free energy change would be minus 409.3 kilojoule if 1 mole zinc reacts. If 10 mole, then we need to multiply by 10. Okay, this becomes 4,000 kilojoule per 10 mole. Okay, so this is important. First, we look at this one, and then we can calculate E cell of the battery. Or when we know the E cell of the battery, we can calculate Gibbs free energy change of this kind of reactions. And then let's look at another question. Will aluminum metal displace copper 2+ ion from aqueous solution? I think yes, because aluminum is active metal and copper is semi-noble metal. That is, will a spontaneous reaction occur in the forward direction for the following reaction? What do you think? I think this is spontaneous reaction. As I said earlier, this is semi-noble metal, and this is very active metal. So aluminum can successfully displace copper 2 plus from aqueous solution. Especially if aluminum can be used in hydrochloric acid solution, successfully displace copper 2 plus. From my experience, I'm telling you, if copper dissolve in nitric acid, I think aluminum cannot displace. Let me write down what I am saying here. If it is in the form of nitrate, and this reaction wouldn't happen. Due to no reaction takes place due to kinetics reasons. Because aluminum doesn't like nitrate ions. On the other hand, if we use chloride, aluminum likes very much chloride ion, and the reaction becomes spontaneous. The reaction goes to forward. Okay, or a spontaneous reaction occur in the forward direction as written here. Let's analyze the question. We need to identify the species reduced in the reaction as it is written. Then we can calculate E cell. If E cell is positive value, then the reaction will occur spontaneously. Either we need to look at the E cell. If it is positive, then this becomes spontaneous reaction, or we can also look at change of the reaction. If Gibbs free energy change of reaction is negative value, then we also conclude that it is spontaneous reaction. Okay, and let me write down here the cell diagram corresponding to the reaction is aluminum solid down into solution and copper ion here reduce into metallic form, and E cell cathode minus E anode. E cell is copper reduced metallic form minus aluminum dissolved in the solution. So E cell minus 167 volts becomes 2.06 volt. It's a high voltage actually. We can use this kind of reaction in batteries, maybe. I don't know if any battery chemistry use this reaction, but this is suitable potential. 4 volt. And now its positive direction of potential is that of the forward reaction. So we can conclude that aluminum solid form displays from active solution under standard conditions. said earlier, Gibbs free energy change or Gibbs energy change when the reaction is negative, and then that reaction is positive. You need to keep in mind that both E and E are intensive properties. Add them together. You need to this intensive property, density, pressure, temperature, etc. And then we cannot combine E cells together. We need to convert delta G. This not intensive properties, extensive properties. They depend on the quantities of metals involved, which means their values are affected by the choice of this. Here, let me write down reaction here. 1 molar. And E cell of this reaction 2.016 volt. And when we write down here 2/3 aluminum solid plus copper plus 1 molar becomes copper solid 2/3 aluminum 1 molar. E cell also same plus 2/6. If we write down here 10, 30, 30, 10 doesn't change because E cell is intensive properties. On the other hand, delta G value depends on these coefficients, and delta G value changes, but E values wouldn't change because it is intensive properties. Is it clear? Let me continue with the another question.
Sorry, sir, can I ask one question?
Yes.
So when multiplying with those coefficient numbers in the equation,
yeah,
the only thing that will change is the number of electrons in the G is equal to, in the Nernst equation, change the number of electrons.
Yes, only number of electrons would change.
Okay.
E cell is intensive properties like density. 1 gram water has a density of 1 gram per cubic centimeter. 1 ton water also same, 1 gram per.
Okay.
Okay, similar thing, similar approach can be done.
Okay, sir.
Thank you for asking. And another question, peroxide sulfate solution, such as sodium peroxide disulfide, are very strong oxidizing agents in bleaching. You know bleaching? Blue jeans can be bleached, for example. This is strong oxidizing agent like hydrogen peroxide can be used. This guy can be used in bleaching processes. Dichromates such as potassium dichromate have been used as laboratory oxidizing agent. Probably you would remember this one. This is also a powerful oxidizing agent. And the question is, which is the better oxidizing agent in acidic solutions? Peroxide sulfate or chromate? In the redox, the answer we need to analyze which one is more powerful. Both can be used as a oxidizing agent. Which one is better? In redox reaction, reduction and oxidation reaction, the oxidizing agent is reduced. Okay, this is reduced from chemical metallurgical laboratory experiment. You would remember this gets 3 electron and reduced to chromium 3+. This is powerful oxidizing agent, and this reduces here chromium 3+. And I would like to tell you that powerful oxidizing agent becomes reduced, and powerful reducing agent becomes oxidized. Okay, for example, aluminum is powerful reducing agent. This means aluminum can easily oxidize. And please do not mix these concepts together. And the reaction tendency is by the aluminum. Let's write down here 2O8 becomes S and E value plus 2.01, and chromium here plus E value is here 1.33 volt. Which one is better oxidizing agent? This one is more oxidizing agent. Inspection of standard reduction potential enables us to calculate the content of a particular redox reaction. So, you know, EMF series, we can choose which one is better oxidizing agent, and also we need to consider economical parameters. We need to take economy into consideration. We can choose most powerful oxidizing agent, and at the same time we can choose most powerful reducing agent. If something precious in the solution, for example, platinum plus dissolve in the solution, and when we add aluminum, zinc, iron, we can successfully reduce platinum metallic form. On the other hand, aluminum dissolve into solution, zinc dissolve into solution, iron dissolve into solution. This is strong oxidizing agents, and these are strong reducing agents. Okay, and then platinum becomes metallic form, reduced to metallic form. So we need to assess the spontaneity of a particular reaction based on EMF series. Any question now?